All right, class, welcome to the last week of research methods. I just wanted to go over a few things, but the main portion of this video will be to discuss the instructions on how to upload your final CAP assignment, which is the full research project write-up, and also what you need to do for the presentation. A few things I just wanted to clear up here. We still have a few assignments due, right? So you got your final exam, which is 60 points. And then you have your critical assignment, research and kinesiology paper, and presentation. So combined, that will be 200 points. And your course evaluation, which will be worth 10 points. So that's a little extra credit there if you guys get your course evaluation done. Remember, you have until the 30th, so you have about 7 days, but just try to get that done as soon as possible so you don't forget at the end there. That's easy 10 points right there. All right, so if you look at the syllabus under week 8, you'll see that the first thing that's due is your research and kines paper. So the actual full completed paper will be due on Thursday. Make sure that you turn that in by Thursday at midnight, and I will go over the instructions on how to turn that in. The next assignment due this week will be the presentation, which will be due Friday. And that, I will also show you how you turn that in. That will be done on the discussion board. And the final thing that you have to do is the final exam, which is going to be due by Sunday at midnight. And I will also go over that, and I'll give you somewhat of a study guide at the end of the video here, so just stay tuned. All right, so first we're going to go over the critical assignment paper. So here you have a little description of what's required for the paper. Now remember, you've been getting feedback for each section of this paper, so by the time at this point, it shouldn't take you very long to put it together, as long as you've been making the corrections that I have been giving you in the feedback. This is the rubric that I'll be using to grade your papers, and it's not limited just to this, but this is where the majority of your points are going to come from, so you can read through each box here and it'll tell you exactly what's required in the paper. So here in the instructions, it tells you to use this template. When you open it, it will be like this. So this will pretty much walk you through everything that you need. So every section that you've created, you can just copy and paste, or if you prefer just to retype it, you can do it on here. But this is what your title page will look like. You just got to put the title of your study, then your name, and then the current date. Next will be the table of contents. As you can see, this is each portion that you will need to include here. So make sure you have this table of contents with the page numbers. And this is the first part, the abstract, the introduction, method section, results section, discussion, and finally references. Now, remember that each page, or I'm sorry, the whole document has to be in the same format. I mean, if you haven't already looked this up, and I know some of you are still trying to work through this, but APA style formatting is very simple. Times New Roman font, 12 size 12 font. All borders are 1 inches. Everything should be double spaced. There's very few examples of when you don't use a double spacing. And then the title page, I'll be pretty flexible with that. You can either put it in the bottom right or in the top right. And if you have trouble with any of this, there's a lot of YouTube videos that you can just look up, just APA style formatting, and they'll walk you through every little thing, how you adjust it with the under the settings. And also you have this resource that I showed you a few weeks ago. This document is on the Purdue OWL website. I told you to download it, keep it, because it gives you a great explanation of how you're supposed to do every single portion of the document. And like it says here, the green boxes tell you the guidelines, and then the blue boxes give you instructions on how you write and how you cite the different references. But really good document to have. It tells you exactly how you're supposed to align everything, how you're supposed to cite each reference. Makes it pretty self-explanatory. And I'll put a link up on the learning activities for this document so you guys will have it. All right, so remember that the critical assignment, the paper, the actual paper that you've written, is due on Thursday night, by Thursday night. I mean, I hope you guys would start turning everything in the next few days, but the absolutely last day to turn it in is on Thursday. Here are the instructions on how you turn that in, and there's also a document here that walks you through each step. In the instructions, you'll see this message on here. So if you're gonna pay attention to one thing in the instructions, it should be this for sure, because this is what is, at least from my colleagues, what they've been telling me is the major problem, or what's causing the major problem with uploading the critical assignment. So make sure that you're using Firefox or Google Chrome. If you're using another web browser, you're more than likely going to have a problem uploading the document. So make sure you open your one of these two web browsers and then follow each of these steps. The first step will be to click on this link here, and that's where you can start following the directions to submit the final critical assignment. If you have any trouble uploading the critical assignment to that link following all those instructions, please make sure you let me know right away so we can get it fixed as soon as possible. And again, remember that is due on Thursday. So the next portion that's due this week is the presentation. And remember, this part is due by Friday. And here are the instructions on what is needed for that presentation. So first of all, you're going to need a PowerPoint presentation. So you actually need to create a presentation on PowerPoint. And this is a breakdown of what you need to include in each slide. And I'm not going to be too particular about how much time you spend on each slide, but make sure that you have all this information in each slide. You need to make sure that you have your name, the name of the presentation, and then in the first couple slides, your background, then the problem statement. So what's your research question and hypothesis? So, just like how you did in your paper. The method section, where you describe your participants, procedures, the instrumentation. Then you also need the statistical tests that you performed. That will all be under the methods slides. And then finally, the discussion. So what you found and where this research could be taken in the future. So this portion is pretty straightforward. Again, there's some time frames here, like what each slide should last or how long you should be speaking on each slide. But I'm not going to be, I'm not going to be too strict on that. This is just to kind of give you an example of how you should break down the presentation so that you have enough time to speak about each topic and that you're not, taking too much time just on the intro, and then you're not giving yourself enough time for the method section and the discussion. And that's going to require a little bit of practice on your part. Make sure that you rehearse, your presentation, write down some notes, and before you record yourself doing it. So remember, the recording is your final product. I mean, that's once you have your presentation down pretty good and you can do it very well without really having to look at too many notes. I mean, you should have your notes right in front of you, but they should just be there as reminders. So once you have your PowerPoint presentation complete, and when I say PowerPoint presentation, I mean once you have all of your notes on slides, you have all the points that you want to make, and you have all these sections accounted for in each of those slides. Then you can record yourself. Then you can actually finish the presentation and record yourself. And that's going to be done through Screencast-O-Matic, or at least this is the website that we are recommending for you to use. It's one of the most easiest. That's one that I use, and that's one I'm using right now. And it's fairly simple to use. All you have to do is go to this website, then you can sign up. It's a free account. There's no need to purchase anything. And there's a tutorial. It can kind of walk you through what you can do with this software. And a couple tips: just make sure that you adjust the window once you open it. So the window will look like this right here. And you can adjust that to capture everything you want to record on your screen. And then what you want to do is click on this option here, because that will record you. So your actual, it'll use your webcam, and it'll capture the rest of the screen as well, all in one. And just make sure that your microphone is working. So once you can check it just by talking, and this these little bars should start lighting up. And from there you can pause and start recording as you like. So if you're in the middle of a point and you need some time to like look at notes, you can just easily pause it. There'll be a pause button. Stop there, gather your thoughts, and then once you're ready again, pick up where you left off and you just hit the record button, and it'll pick up where you stopped recording. Finish the recording, you can just hit the button that says done, and it'll ask you where you want to upload it to. So you can upload it to Screencast-O-Matic's website, and that's what I would recommend you do. There's different ways to upload it to YouTube and to other websites, but for the purposes of this class, I find it much easier if you just upload it to Screencast-O-Matic. And then, so I have like this video here already, and I can click on it, and then I can just copy the link. So let's see. So if I click on my video here, I can click on this link embed link there, and then all I want to do is copy and paste this link here. So if I do that, and depending on whether you have a Mac or a PC, you can hit Command C, and that will copy this link, or you can just right click and copy this link here. And then once you get to your discussion board, you can paste that link there. So speaking of discussion boards, that is how you will submit this presentation. You will click on the discussion board link just as if you were going to create a thread for a discussion, and just give a quick message saying, here's my presentation, please provide feedback as needed, and copy that link onto there, the one that you copied from the Screencast-O-Matic website. So a few things about this portion of the assignment. So once you've posted your link to the presentation, and remember that has to be done by Friday at midnight. And remember, it also should be 10 minutes long, so about 10 minutes long. I mean, you don't want to go too much longer than that, and you definitely don't want to make it just 5 minutes, but around 10 minutes should be okay. It tells you here it should be as a YouTube link, but like I said, I think the way I just showed you will probably be the best way to do it. If you do it as a YouTube link, that's fine as well, as long as we can view it. The next thing that you should do is ask 1 to 2 questions related to the research topic. So that means you then have to view it says 2 of your classmates. So you have to view 2 other classmates' videos and ask 1 or 2 questions about their research, the topic, methods, findings, whatever you find interesting and that you have a good question for, make sure you do that. So you have to respond to 2 classmates, 1 to 2 questions. And finally, the last thing you must do on this is moderate your thread. So everybody who's posting questions to your presentation, you should give them an answer, or provide some sort of explanation, or further the discussion on your own thread. And we want to make sure that everyone gets involved with a discussion, of your own post. So make sure that you're responding to someone that doesn't have any responses or only has 1 response. But if someone already has 2 or 3 responses to their thread, then choose someone else's presentation. Last thing I want to go over is the final exam. It's going to be a comprehensive exam, so everything that we've covered from week 1 to week 7. Make sure that you allow yourself 2 hours to complete this exam. Once you start, you cannot pause it and restart it. You have to finish it all in one sitting. And let me cover a few things here that you guys will need. So you're supposed to do this exam on your own. You can use your textbook, the slides, all the PowerPoints, with different handouts that were attached to the learning activities. But you want to make sure that you kind of know what's going to be on the test, and that's what I want to help you with a little bit here. So as far as the structure, there's 57 questions. There's true, false, multiple choice, and matching. So all the questions are pretty much structured just like the questions that you've seen on your quizzes. And in fact, some of them may be pretty similar to the ones that you've seen on your quizzes. Next are the topics. So I just want to give you a little list here of approximately how many of each question or each topic you're going to see on the exam, so that nothing really catches you by surprise. First is ethics. So ethics and the Belmont principles, those you'll find on the handout that was given in week 2 when we covered ethics, and you'll be able to pick out what the information that you need from there, and also the information that's included in the informed consent that's also on that document. Next is descriptive statistics and scales of measurement. Here you have quite a few questions on these topics, so make sure that you review the chapter on that. But just to kind of give you an overview of that, the descriptive statistics include the mode, mean, range, standard deviation. Make sure you know how to calculate those. Scales of measurements, those you should be pretty familiar with, but I know some of those concepts can be kind of hard to understand. But the 4 scales of measurements that we use are nominal, ordinal, interval, and ratio. When you see continuous scale of measurement, that's the major heading that they use for interval and ratio. So if you want to group those last two, interval and ratio, they can be grouped under continuous. So make sure you remember the domains of human performance, which are the cognitive domain, the affective domain, and the psychomotor domain. The one that we work in is where we talk about health-related exams and skill testing. All that is under the psychomotor domain. So just remember to review those and understand what is measured under each of those domains. Next is the correlation coefficient, which helps us understand reliability. Now remember, there's different kinds of reliability and validity, and those you can read about those in your textbook, but the main or the most basic concept or the most basic aspect of the correlation coefficient that you need to know about is the linear relationship, meaning when we run a Pearson product moment, which is the lowercase r, what that is telling us is how one variable correlates with the other. So if it's a high and positive r, so remember an r only goes from -1 to +1 and everything in between. So whether you have a negative, let's say 0.9, or a positive 0.9, those are going to be very high correlations. The negative and the positive are only telling you in what direction, negative or positive. So if, let's say, body weight correlates very highly and positively with 1 RM bench press, that's telling us that as your body weight goes up, so will the measurement of the 1 RM. So the higher or the more weight you'll be able to produce in your bench press as far as the 1 RM goes. Now an example of the opposite of that, or a negative correlation or an inverse relationship, as your book states it, would be if, let's say, we had a group of participants, from with different weights, and we correlated their weights with pull-ups. And I believe this was an example in your book as well. Maybe we get a negative correlation, meaning as body weight goes up, the number of pull-ups goes down. That would be a negative correlation or an inverse relationship. And so how does this apply to when you're performing a study and you're calculating different measurements and you want to compare means of different groups? Well, the correlation coefficient, I believe I explained this in one of the discussion board threads, but you don't always use a correlation coefficient to explain reliability. It's a specific case. In interclass reliability, that's when you use the correlation coefficient. that formula or that calculation, where the R will tell you how reliable two measurements were. And that is test retest reliability, meaning you use the same instrument on the same group of people at one point in time, then you wait a little bit of time and you test them again. So you take those two measurements, or the means of those two measurements, and you run that Pearson product moment calculation, and there should be a high correlation, right? As one goes up, the other one should go up. They should both be measuring pretty much the same thing. And aside from that, you also have all these other types of reliability: equivalence reliability, split halves reliability. And for those, you use different statistical analyses to provide reliability. So it's not always that the ppm will, or the small r will tell you reliability. In other cases, you have to use other statistics to verify that. So next is the t-test. The t-test, if you remember from your calculations, is trying to tell us, or we want to find out, what we want to find out when we run a t-test, if there's any difference between the means of two different groups, or in other cases, if there's a difference in means between two measurements at different points in time. And when do you know which to use, the independent or the dependent test? So the independent test is meant to be used when you have two separate groups. So let's say you have a control group and an experimental group. You did the VO2 max test on both of them. So you want to compare those two measurements, the control groups and the experimental groups. You run an independent t-test to find a difference in the means of those measurements. And so when do you use the dependent t-test? The dependent test is when you want to compare the means of just one group. So let's say you just want to test the VO2, the 2 max measurements of your experimental group, but you want to compare the pre-training measurements compared to the post-training measurements. That's when you use the dependent t-test. We have objectivity. So all I want to say about that is just to understand the fundamental concept of that. Objectivity is essentially inter-rater reliability, meaning that no matter who gives the exam or who gives a measurement, the measurements are going to be very consistent from one rater to the next rater. So even if I, let's say, give an exam or I perform a measurement, and let's say tomorrow, my colleague performs the same test or the same measurement, we're going to get very similar results. The example that your textbook gives you is an exam. So if you give an exam that has multiple choice, true, false, and matching questions, just like the final exam that you're about to take, that's going to be very objective, because there can only be a certain correct answers. There's no chance for me to say, oh, I think that question or that answer should have been B instead of C. No, there's going to be a predetermined correct answer. What would make this less objective, or an exam less objective, is if we gave you an essay. If you were supposed to write a short answer or a short essay, that would lower the objectivity of the exam, because now a lot of your grade is going to depend on what I think is a correct answer compared to, let's say, what my colleague would think is a correct answer. Our scores aren't going to be as consistent as if you were given a multiple choice question. Next is validity. So when it comes to validity, the first thing you must understand that a test or a measure must be reliable before it can be considered valid. And it doesn't work the other way around. A test doesn't always have to be valid for it to be reliable. But for our purposes, I want to I'll give you an example here, because validity is going to be, if you could get any measure for any exam to tell you, if you want to use the test or not, validity is what you want. That's what the measure that you want to have, so that you'll feel certain that what you're about to measure, you'll be able to get good results from. In a study, if you want to show validity, let's say a lot of you have chosen VO2 max as your dependent variable. Now, you're not going to be able to, most of you may not have access to a treadmill with the correct equipment to measure expired gas and be able to measure total um, aerobic capacity. So you may have to use a different test, a submaximal test, a Rockport test, something that has been validated. Well, for you to show that that test is valid, you can also compare those scores to the scores that were done on an actual VO2 max test on a treadmill. So let's say if we measured one of our groups with the standard VO2 max test and then also tested them on a submaximal test. We can then take both of those scores and show that that submaximal test is valid. And the way we do this is through the Pearson product moment calculation. So here's another example that the ppm, or the lowercase r, can be used to show validity. Now, I know you're saying, okay, that's a reliability test though. Yeah, but in this case, we're taking the gold standard, which is the VO2 max test, and we're taking a submaximal test, and we're showing that, let's say, a person who got a 30 on the submaximal test got a 32 on the VO2 max test, and we're able to show that the R value for those two scores is, let's say, 0.8. That's telling us that those two tests are going to have a positive relationship, that the scores that you get from both of those tests are going to be very similar, and that gives us that's a good way for us to show our readers that, hey, these two tests are very similar, they have a relationship, so that means it's a valid test. Kind of going along with that example there, you should also be very aware of what makes a dependent and an independent variable. Dependent variable is the actual measurement that you will be taking and the measurement that you want to compare between groups. So in this case, we have two groups. Let's say one is going to go through high intensity interval training and the other group is going to go through continuous aerobic training. But we're going to test both of them on VO2 max. So VO2 max would be our dependent variable. That's the one measurement that is going to tell us whether one group did better than the other group. The independent variables are the variables that we can manipulate. And when I say manipulate, I mean we can decide who gets this variable, who doesn't get this variable. We can change the time frame. Anything we want to do, we can manipulate, is done through the independent variables. So that is, in this case, that would be the training protocol, right? So it would be, we decide that one group is going to do high intensity interval training, the other is going to do continuous aerobic. The independent variable is not, or you don't count each of those as an independent variable. The independent variable is just the training type. This variable, the independent variable, can have different levels though. So don't get too confused with that, but essentially that's what it comes down to, is like, what am I really measuring to compare my groups? What am I changing between those groups to show that one will be better than the other? All right, the last thing I want to really get into is testing hypotheses and how to actually state when there's statistical significance. So remember, in your research project, you have a null hypothesis and you also have an alternative hypothesis. The null hypothesis is the statement that says that, well, in most cases, that there will be no difference between two groups, or no relationship between two groups. The alternative hypothesis, which you made up, usually states that there will be a difference or there will be a relationship. And you can have a directional hypothesis, meaning you can state which one you think will be better. So for example, you can say the alternative hypothesis is that the high intensity interval training group will produce higher VO2 max measurements compared to the control group. That would be a directional alternative hypothesis. So how do you prove whether the null hypothesis or the alternative hypothesis is correct? Well, that's when you need a statistic to tell you whether there is a difference between these two groups. And when I say a difference, I mean we're taking that measurement, that VO2 max measurement, that's what we really want to test, or the measurements of that VO2 max. So we want to be able to show that there is a difference. So we have to take the mean of each group, right? So the average of each group, the control and let's say the experimental group, and we want to compare those two groups. Now, what statistic are we going to use? Well, if you look on page 73, there's the most basic explanation of what you're supposed to do. In the middle of the page, it says the number of groups and level of measurement of the data determine the appropriate statistics to use, and then it says some of the most common are these. So you have the chi-square test, the t-test, and the ANOVA. And once you get your results, you have to interpret that, right? And how do you know how to interpret that? Well, usually your alpha level will be less than 0.05, or your p level will be it's set to be at 0.05 or less than 0.05, meaning that if you look at the matrix that is produced when you produce or run those statistics, if it is less than 0.05, then you can say that there was a statistical difference or a statistical relationship between the two measurements. So anything above that, you cannot say that. You can't say that there was a statistical difference there. So what does that mean as far as your hypotheses? Well, that means that if it's less than 0.05, so if p is less than 0.05, then you can accept first of all, you can reject the null hypothesis, and then you can accept the alternative hypothesis. If you get higher than a p of 0.05, then you have to accept the null hypothesis and you have to reject the alternative hypothesis. So to further explain each of those tests, the chi-square test, the t-test, and the ANOVA, make sure you go through pages 73 through 85, and it'll give you a breakdown of when each test is used and how to interpret it. And then these are the last few topics that you'll see on the final exam as well. Make sure you cover these topics and you understand them. Let me know if you have any questions on this before you take the exam. I'll try to answer as best as possible to give you a better idea of what to expect on the final exam. But otherwise, good luck on the exam. Also let me know if you have questions on the critical assignment, the actual paper, and on the presentation. I wish you guys the best. I know you guys are doing your best and that you've done your best in the whole 8 weeks. I know this is a very tough class, and it's not something that comes easy to most people. So it definitely takes a lot of effort to understand the concepts and to do well on the exams and on the writing. But up to this point, you guys have done, for the amount of stuff you have to do in the short amount of time, you guys have done really good. So let me know if you have any questions. Let me, however I can help you, I'll do my best to point you in the right direction. All right, thank you guys, and have a great week. And I'll be looking forward to reading your papers and seeing your presentations.